And the next type of testing that I want to talk about is full spectrum solar simulation using metal halide bulbs. So similar to xenon arc testing, this is going to focus on the entire solar spectrum. So UV, visible, and also infrared. We also have control of parameters for this type of testing. So you can control your temperature, irradiance, and your relative humidity. And as you can see from that picture, with full spectrum solar simulation, you're actually in a true climate chamber. So you're going to have a lot more room for test parts. You can pull a lot larger parts in here. And also your control parameters such as temperature and humidity are going to be a lot wider. So you can actually hit a lot more extreme temperatures such as extreme lows and extreme highs, and you're going to have a little bit more control over relative humidity as well. So oftentimes for full spectrum solar analysis, we are testing automotive interior components. And in that case, we will usually use solar boxes. And these solar boxes are going to be used to simulate actual vehicle interior conditions. And the way it does that is by allowing the greenhouse effect to take place. So I'm sure you're all familiar with if you take your car and park it outside and leave it there for a while, you're going to have a temperature inside the vehicle that's going to be much higher than the ambient temperature outside. And that's because you're going to have this radiation coming in through the windshield and through your side windows, and some of that heat is going to be trapped inside the vehicle. So that temperature is going to increase quite a bit. So by using solar boxes, we can get that same kind of effect. We can have a higher temperature inside the solar boxes than is actually the ambient temperature in the chamber itself. And when we create these solar boxes, there's a few different parameters that we have to keep in mind and that we have to control. Some of them being airflow velocity. And the way that we can control that is by the actual geometry of the solar box itself, and then also by utilizing air holes. So if you look at the diagram on the right, this is a basic diagram of a solar box. And you can see I've pointed out multiple air holes at the bottom of that solar box. And so those can be plugged or opened up to help regulate the airflow velocity. Also, window composition is going to be important. You want to use the same composition that's in the actual vehicle. And we also perform what's referred to as temperature layering. So if you look at all those different locations I've pointed out in the diagram, those are the different locations that we take temperature measurements. So we'll actually place thermocouples in these various locations to make sure that we get the correct type of temperature layering that we look for. We also are looking at relative humidity and then also the windshield angle. And the windshield angle is actually going to have effect on some of these other parameters, such as mostly your temperature, and it can affect your relative humidity a bit as well too. And typically these parameters are all going to be defined in either your test specification, or they're going to be, you're going to want to match them to the actual vehicle that you're testing. And this is just an example of an image of a solar box that we created here at J.A. King. It is somewhat configurable. We've got holes in the side of the box that can be plugged or opened up. And then also the windshield angle can be changed based on the actual parts that we're testing.